Hello everyone, in this video I give you a brief introduction about calculus. Calculus was co-invented by Newton and Leibniz, so they were co-inventors of calculus. But the ideas were too complex and not for laymen, so there were many complex ideas which could not understood by a layman. And later Cauchy, he modified the ideas that were given by Newton and Leibniz, so he is known as creator of modern calculus. So he made calculus more accessible so that people can understand it. More accessible, and also he developed the theory of limits. The theory of limits, and also there were some problems that were not solvable before calculus. So we're going to take a brief look at the problems which were major problems which were solved by calculus. All right. So first problem was how to figure out an instantaneous rate of change or instantaneous velocity. So we know that what is the average velocity? So it's easy to find the average velocity. So average velocity is total distance, change in distance. So delta means change. So change in distance over change in time. So for example, let's say a person has covered 130 kilometers in 2 hours, and we can figure out average velocity by dividing 130 with 2 hours, and we say that the average velocity is 65 kilometer per hour. But what about the instantaneous velocity? Instantaneous velocity. So if we think of this, so it means at any time distance over change in distance over change in time. So at any particular moment, the change in distance is 0, change in time is 0, which gives us 0 over 0. So this was an unsolvable problem in Newton times. So unsolvable problem in Newton's time. But we were able to solve it after that using the theory of limits. So another problem that is solved by calculus is how to find the slope of a function at a specified point. For example, so if you want to figure out the slope at a specified time, it means we're talking about the slope of a tangent line. And tangent lines are the lines which touch only at one point. So this line is touching the function or the curve at only one point. Only at one point. So if we want to figure out the slope in general, so we know that slope is change in x over change in y. So for example, if we have a secant line, it's easier to find. So this is our secant line which cuts the curve at 2 points, and the tangent line is the line. So tangent line is the line which cuts the curve only at 1 point. So, and slope is change in x over change in y. So slope of tangent line, slope of secant line could be determined, but slope of secant line could be determined, but the problem was how to find the slope of tangent line because it's again 0 by 0. So change in y is 0 over change in x is 0. So how to find slope of tangent line? So again, calculus solved this problem for us. So next we want to find, so another problem that calculus solved was how to find maxima or minima points without graphing. It's easier to find the points of maxima or minima. If you have a graph, you can just look at the graph. But how to find these points without graphing? So calculus also helped us to solve this problem. So in this case, so we can see that these are the points of local maxima, and similarly we can see that these are the points of local minima. And lastly, the other main problem that calculus solved for us was how to find the area of irregular shape. So how do you find this area? Find this area if fx is the curve. So calculus also helped us to solve this problem. Alright, so here the problems 1, 2, 3, instantaneous velocity, slope of a function at a specific point, maximum and minimum value of a function. So problems 1, 2, 3, these were solved by branch of calculus which is called differential calculus, and problem 4th is solved by the branch of calculus which is known as integral calculus. In the future videos we will discuss, we will learn something about differential calculus, and also we will learn briefly about integral calculus. So far, it's important to know what calculus looks like. So in calculus, if you look at any calculus textbooks or if you look online, so you will see the different symbols. So you will see something like this. So this is the notation for the derivative of a function. And if the function is y is equal to fx, so this is same as derivative of y with respect to x, dy over dx. So basically you will see a few things in the calculus, dy, dx. You will see x and y are, if x and y are variables, y is the dependent variable, x is the independent variable, and you will see like there is notation delta or d. So this will be used for a tiny bit. So this represents tiny bit, like very small change. And you will see that we use the wording like derivative of a dependent variable. So in this case, derivative of y with respect to independent variable, which is x. And then also you will see that there will be some problems relating to this notation. So this is called limit x approaches to infinity. So this notation is for asking, So this is a notation for asking what happens to the function when x approaches to a certain value. So what happens to function when x approaches a certain value? So when we discuss the differential calculus, so we're going to start with the topic of limits. So this is a notation for limits. Similarly, we will see that later in our integral calculus that this symbol is for integral. So it means it's basically like adding up the sums. So integrate. So integral, so that means to add up all these tiny little bits. So means to add up all the little bits of the function. So little bits of x. So we will learn about these topics in detail. So there are different methods that we can use. You will use some algebra, you will use some graphing, we'll talk about functions. So basically whatever you learned in your pre-calculus, we're going to use all that information in our calculus course. So please do watch the next video to see how we work with the limits. So we will discuss different methods of finding the limits in next video.